Lesson 1.2, Product Rule. The goal is to answer the question, how do we count the number of possible lists? Let's begin with an example. How many possible lists could we make with the following objects? Zebra, owl, and camel. We will list these out by hand while trying to employ a sort of systematic approach. A quicker and slightly less tedious way to represent all possible lists is using a tree diagram. There are three possibilities for the first element of the list, namely zebra, owl, camel. If our first choice was zebra, then the options for our second choice will only be owl and camel, since objects cannot be repeated in this example. If our first choice was an owl, we can either choose a zebra or a camel for our second choice. If our first choice was a camel, we can either choose an owl or a zebra for our second choice. For our third choice, there will only be one option left for each of the second choices. For instance, the list zebra, owl, camel is represented by following this path. The list camel, owl, zebra is represented by following this path. As you can see, there are three options for the first choice, and for each of those three options, there are two options for the second choice, and for each of those two options, there is one option for the third choice. Therefore, the total number of paths, which is the total number of lists, would be 3 times 2 times 1, which is 6. Let's consider another example. Julia has to pick colors for her 2 front porch lights. The color options include red, purple, blue, and green. How many possible ways can this be done? Let's use a 2-element list where the first element is the color of the first light and the second element is the color of the second light. For instance, we could have the list red, purple. Let's construct a tree diagram to represent this situation. For the first choice, there are 4 options: red, purple, blue, green. For each of the second choices, there are the same 4 options, since repetition is permitted in this situation. For instance, the list red-purple can be represented by this path on the tree. There are 4 options for the first choice, and for each of those, there are also 4 options for the second choice, which means the total number of paths, which again is the total number of lists, would be 4 multiplied by 4, or 16. These examples should aid towards making the following rule quite intuitive, and that is the product rule for counting, which states the number of total possible lists is equal to the number of possibilities for the first element multiplied by the number of possibilities for the second element, and so on. Let's see the product rule in action. 3 brothers must pick their seats in the back of a car. How many arrangements are possible? This is a good application of lists since order matters. There are 3 options for the first seat or first element. For each of those, there are 2 options for the second seat or second element. And finally, for the third seat or third element, there is 1 option. Therefore, the total is 3 multiplied by 2 multiplied by 1, or 6. Exercise. John wants to order his 4 favorite books from best to worst. Represent this situation with a tree diagram and then state the number of possible ways he can order his books with reference to the product rule.